So we're going to look at solving inequalities today. So we've been looking at solving equations. So those are where you have expressions with an equal sign in between them. We're going to now look at solving inequalities. So we are going to have either a less than or equal to, a greater than, or a greater than or equal to sign instead of an equal sign. So hopefully after we talk about this, you'll be able to use interval notation to represent an inequality, use properties of inequalities. You should be able to solve inequalities and solve combined inequalities. Okay. So let's just kind of review a little bit on notation of inequalities and what an inequality is. And I didn't realize when I pulled these notes that they were my 1.1 notes. Okay, so looking at inequalities. So inequalities, again, involve expressions that are separated by an inequality symbol, less than, greater than, less than or equal to, or greater than or equal to. To solve inequalities means to find all values of the variable for which the statement is true. Because of the inequality, the solution set involves a range of answers where formal notation is needed. Okay, so looking at the following, we have that let A and B represent two real numbers, and we're going to be given that A is less than B. So a closed interval is denoted by brackets. And if we had a closed bracket and then we have A, comma, B, and then a closed bracket, this consists of all real numbers X, such that X, where A is less than or equal to X is less than or equal to B. If you're given an open interval, so we would denote it with a parentheses, so A, comma, B, end your parentheses. We're saying that this consists of all real numbers X, for which A is less than X, which is less than B. So sometimes we might have an open interval and a closed interval, or vice versa. So the half open or half closed intervals are maybe looking like this. So A, comma, B, bracket. So this is consisting of all X for where A is strictly less than X, but X is less than or equal to B. Or we might have bracket A, comma, B, parentheses. And this is if A is less than or equal to X, which is less than B. So we put the closed bracket if it's including that inbound of our inequality, and we put the open bracket if we're getting very, very close to that number, but not including it. So in each definition, A is called the left endpoint and B is called the right endpoint of the interval. If an interval is unbounded, the symbol either of infinity or negative infinity is used. So this always involves open intervals when we're dealing with infinity or negative infinity. The question is, why would we look at open intervals when we're using infinity or negative infinity? Well, that's because when we're going off to infinity or negative infinity, we're not stopping at one value that's included. It's continuing to grow. And so we're not including a particular number there. So looking at the following, we have set builder notation, and inside that set builder notation is our inequality. And through here, we want to look at this and we want to give the interval that represents the inequality, and we want to graph our number on the number line, our solutions on the number line. So looking at the following, the set builder notation, that curly bracket. So this is the set, the variable x. This vertical line means such that A is less than x, which is less than B. So A is less than x, but is less than B. And so it's not including A and B, so we're going to put parentheses A, comma, B in parentheses. If we're graphing this on the number line, this is including all the x values ranging from A to B, but not including. And so if we're not including it again, we're going to put parentheses. And we're going to shade everything that's in between. So any number that falls in between those two values, A and B, are part of our solution set. You may see it depending on what you're looking at, but you might see that if it's not included, another way that we could have written this are with open circles. So from A to B, we're going to have an open circle at A, and an open circle at B, and we're looking at everything that is in between those two. So I tend to like to use the parentheses because that's the same thing that we're using for our interval notation. So you should be able to go through and set up all the interval notation for the inequalities in this table, and you should be able to graph these. So the second one says that x such that A is less than or equal to x is less than or equal to B. If we're including the n value, we put a bracket. So we're going to have bracket A, comma, B, bracket. Again, we're looking at all values from A to B. But this time we're including those values. So we have a bracket between A and B. If we were to do this another way to represent on the graph that we're including a point is a solid circle. And so because we're including our endpoints A and B, in this case, we would put a solid circle on A and B and shade everything in between. So the next inequality, A is less than or equal to X, which is less than B. So one of the n values is included, one of them is not. We're including A, so we put a bracket. And then we're not including B, so we put a parentheses. So graphically, we're including A, so bracket on A, not including B, so parentheses, and shade everything in between. The next interval notation we're going to do is for A is less than X is less than or equal to B. So A is not included, so we do parentheses A, comma, B. B's included, so we put a bracket there. Starting at A, not including it, getting as close as we can, going to B and including it. So parentheses on the left endpoint and a bracket on the right endpoint. So for the next inequality, we have X is greater than or equal to A. So everything that is bigger than A and including A. So we're going to include A, so we're going to put a bracket. But it's anything that's bigger than A, so we're going off to infinity. So locate A on the number line. You're including it, so put an open bracket there. And we're going on forever, so I'm just going to shade everything to the right, and then my arrow, I tend to just kind of fill it in, showing that that's going on forever. If we're strictly greater than A and not including A, we're going to just put a open parentheses on the left endpoint, a comma infinity parentheses. So parentheses on A, shading everything to the right. Where if we're have X and X is less than or equal to A, okay, we're coming in from negative infinity. So we have a open parentheses, negative infinity, and then we're going to A, we're including A, so we're going to put a bracket. So locate A on the number line, bracket on A, but shading everything to the left because it's smaller than. Where if X is strictly less than A, then we're going to have, again, parentheses, negative infinity, comma A, not including A, so we put a parentheses there. Locate A, put a parentheses on A, and shade everything to the left. In the last case scenario, it says X such that X is a real number. So we're looking at our whole real number system. And so you're looking at everything coming in from negative infinity. So parentheses, negative infinity, comma, and going to infinity. So infinity and your parentheses. So on the number line, we're shading in everything. Okay, so interval notation is something that we use a lot in mathematics. We'll look at where graphs are increasing and decreasing, where they're constant, and putting these in interval notation is usually a preferred method. So we'll be doing this a lot in this course. So you should be able to write the interval notation for the given inequalities in this first example. So I'm actually going to let you guys do that really quickly as I pause the recording, and then we'll talk about it. Okay, so you should have had time to do the following examples in front of you. Looking at this, we have -2 is less than X, which is less than or equal to 0. So I'm not including -2. -2 is the smallest value. Always go from smallest to largest. Not including -2, so we have a parentheses on the left hand endpoint, and then we're going to 0, but we're including it, so we're going to put a bracket. So we're shading everything in between -2 and 0, but we're not including -2, so we can denote that with an open parentheses on the left-hand endpoint and a closed bracket on the right-hand endpoint. Part B says X is less than 3, and so we're coming in from negative infinity, and we're going to 3, and then we have an open parentheses. So we have everything shaded on the left until we get to 3 with a parentheses. And then the last case scenario, we have -1.5 is less than X is less than 3. So we're looking at coming in from -1.5, not including it. So it's an open parentheses, comma 3, close parentheses. Not close parentheses. Yeah, close parentheses. And then we're looking at everything from -1.5 to 3. So we're shading everything in between. We're not including those end values, so we have parentheses on those end values. So the next example in here, this time you're given the interval notation, and you want to write the inequality notation for the interval notation and graph each interval. So you should be able to rewrite the close bracket, -4 to 2, close bracket, and inequality notation and graph it. Parentheses 3/4 to infinity, and parentheses 0 to 4, close bracket. Okay, close bracket tells us that we're including the end value of that inequality. And so we're including -4. So we have -4. This is less than or equal to x. And then it's less than or equal to 2. 3/4 to infinity. So x has to be bigger than, but not including 3/4. So x is greater than 3/4. And then the last interval notation, we have 0. It's a parenthesis, so it's strictly less than x. And then we have a closed bracket on 4, so this is less than or equal to 4. Going ahead and graphing these. Okay, so -4 is less than or equal to x is less than or equal to 2. So we're shading everything in between -4 and 2. We're including both of those end values, so we put brackets. X is bigger than 3/4, so we have a parentheses, and we're shading everything to the right. And then x is between, but not including 0, but including 4. So shade everything in between 0 and 4 with a parentheses on 0 and a bracket on 4. We now have some properties in front of us, the non-negative property. So for any real number a, if we square a real number, this is always going to be greater than or equal to 0. We can't square a negative number and get back a positive number. And so if we have a square, we know that squaring that, and it's a real number that we're squaring, that has to be greater than or equal to 0. We have the addition properties of inequalities. So if we have A, B, and C, they are all real numbers. We're given that A is smaller than B, then addition properties, sorry. A plus B. A, if I have A is less than B, technically I could add something to both sides of the equation. And let me add C. So A plus C is less than B plus C. I keep on writing B there. If A is greater than B, then I can still add a constant C, and it's still going to be a true inequality. True or false? 3 is less than 5. Well, that's a true statement, right? 3, if we look at the number line, is smaller than 5. So now multiply each side of the inequality by 2. Do you agree with the statement being true or false? Well, if I look at this inequality, 3 is less than 5, and I multiply both sides of my inequality by 2, I get 2 times 3 is 6, is less than 5 times 2, which is 10. So multiplying by this positive number 2 remains that my inequality is going to be a true statement. So this is still true. So true or false? 3 is less than 5. Well, yeah, we just said that 3 was less than 5, so this is true. Now, though, if we multiply both sides of our inequality by a negative number, in this case, -2, is that statement going to be true or false? So if I look at 3 is less than 5, and I multiply both sides of this inequality by a negative number, we get that -6 is less than -10. Well, if you look on the number line, -10 falls to the left of -6. And this is not true. This is false. So there's a rule, and this is the only really rule that we need to remember. Every other case works when we're using our properties to solve the inequality. It's just like we were solving with an equal sign. The only thing is that if we multiply by a negative number, then we have to flip our inequality sign. So what we just talked about leads to these multiplication properties of inequalities. So if A is less than B, we're multiplying both sides by a positive value, then AC is still going to be less than BC. But if we have A is less than B and C is a negative number, and we multiply both sides by a negative number, then this AC, this is now going to be bigger than, so greater than BC. If we have A is bigger than B, C is a positive number, then we can multiply a positive number to both sides of our inequality and it's going to remain true. So AC is still bigger than BC. But if A was bigger than B and we multiplied both sides by a negative number, then that's going to flip my inequality. So AC is now going to be smaller than or less than BC. So if we multiply by a positive number, keep the inequality signs the same. If you multiply by a negative number, you need to flip that inequality sign. There's a reciprocal property that is helpful and something that you'll use once you get into calculus to help us prove stuff. But in this case, it says if you have a positive number A, which is bigger than 0, then 1 over A is also going to be bigger than 0, right? 1 over a positive number is still positive. So if B is greater than A, which is greater than 0, then 1 over A is actually going to be smaller than 1 over B, but they're still both going to be bigger than 0. So, and they switch the things to on the side. So if I have a smaller number, and I divide by it, then it's going to be larger. So B is bigger than A. So 1 over A is going to be greater than, in this case, 1 over B. If A is smaller than 0, then 1 over A. So if you take 1 over a negative number, that's still negative. So this is going to be less than 0. If A is smaller than B, and that's smaller than 0, then 1 over B is going to be smaller than 1 over A. And this is still going to be less than 0. So looking at the following, we have the inequality that x plus 3 has to be smaller or is less than 3x minus 7 by performing the following steps. You want to do the following. So part A, when you're solving an inequality, you're going to solve it just like you were solving an equal sign if it's linear. You're going to get all the variables to one side of the equation, and you're going to get all the constants, the terms without the variable, to the other side of the equation. And so I want all my variables. Let's get all the variables to the left-hand side. So that means I don't want this 3x on the right-hand side of the inequality. Subtracting a number is not going to change the sign of my inequality, so I'm just going to subtract 3x on both sides. So 1x minus 3x, this is going to give us a negative 2x. Let's subtract 3 on both sides. So this is less than. Sorry, less than. Negative 7 minus 3, which is negative 10. So we want to get the x by itself. So to get x by itself, we can think of it as multiplying by negative 1/2, or we can think about it as dividing by a negative number. So multiplying or dividing by a negative number, this is going to flip my inequality sign. So this is now going to be a greater sign. And so we get x is greater than negative 10 divided by negative 2 is 5. So I kind of skipped the steps that it gave me and just did it. So write your solution as self-builder notation and then graph it. It also says write your solution in interval notation. So we have everything that is bigger than 5. So we're looking at parentheses 5, and then we're going off to infinity in parentheses. We have a curly bracket x, vertical line such that, and then the inequality x is greater than 5. Number line, find 5. We're going to put a open parentheses, and then we're shading everything to the right. Yes. So same exact thing as if we would solve the next inequality, like an equation. First thing you want to do is you want to simplify down each side of your inequality. So we have the example 2 times the quantity y minus 3 in that quantity plus 8y. This is strictly less than 4y plus 10. So first thing I want to do is let's distribute the 2 inside the parentheses. And so we get 2 times y, or 2y, minus 2 times 3, so 6, plus 8y is less than 4y plus 10. So we're combining like terms. On the left-hand side of the equation, I have a 2y plus an 8y. That gives me a 10y. And down the minus 6 is less than 4y plus 10. We've simplified both sides of the inequality down. So now our goal is to get all the terms with a variable to one side of the inequality and all the terms without the variable to the other side. So let's subtract 4y on both sides of our inequality. And let's add 6 to both sides of this inequality. So doing so, I get 10y minus 4y. This gives us 6y is less than 10 plus 6, which is 16. We want to divide both sides by 6 to get y by itself. I'm dividing by a positive, so my inequality is going to stay the same. So we have y is less than 16/6. So we want to reduce this down. I see 16 and 6 both have 2 in common. 2 goes into 16 8 times. So I have 8 in the numerator, and 2 goes into 6 3 times. So I have y is less than 8/3. if I was going to write that in interval notation, I would have coming in from negative infinity. So I have a open parentheses, negative infinity, and I'm going to 8/3. I'm not including it, so close the parentheses. This is parentheses. Locate 8/3 on the number line. And we're shading everything to the left of 8/3. We're not including 8/3, so we're going to have a parentheses. So the next inequality we have is x minus 4 is in our numerator, is all over 3. And then we have plus 3 outside of that fraction is less than or equal to x all over 8. So recall when we had equations and we had fractions, we cleared our fractions by multiplying 3 by the LCD. We can do the same thing when we're dealing with inequalities. So I would look for my least common denominator. I have 3 and 8 in my denominator. So the smallest thing that both 3 and 8 divide into is 24. So our least common denominator is 24. So we want to multiply both sides of our equation by 24. So I'm looking at 24 times x minus 4 all over 3. I'm technically multiplying this on both sides of my equation, so I have to distribute that 24. So then I would have plus 24 times 3 is less than or equal to x times 8, and I have to multiply 24 on this other side of the equation. So doing so, multiplying by the least common denominator, fractions go away. And so I see that 3 goes into 24 8 times. So I technically have an 8 times my numerator x minus 4 here. So let's distribute the 8 and bring that down. So I have 8 times x, or 8x, minus 8 times 4, or minus 32, plus 24 times 3 is 72, is less than or equal to, well, we can simplify here. We see that 8 goes into 24 3 times. So we're left with 3x. So I noticed that the left-hand side of this inequality, we can simplify by combining like terms. So there's no other term with an x on the left-hand side, so let's bring down that 8x. But we have a negative 32 plus 72. So this is plus 40 is less than or equal to 3x. So it's up to you. You can get the variable to the left-hand side or the right-hand side. But when you write out your solution, you should put the variable on the left-hand side. To me, it makes a lot more sense of what's going on. Let's just move that variable to the left-hand side. So if you subtracted 3x on both sides of your equation, we have 8x minus 3x. So this is going to give us 5x. Let's subtract 40 on both sides of the equation. So we have less than or equal to negative 40. So I just moved my variables to the left-hand side of the inequality, my constant on the right-hand side. Get the variable by itself. We could divide both sides through by 5. I'm dividing by a positive number, so this is not going to flip my inequality. And so I get x is less than or equal to -8. So I have everything from -infinity, comma, to -8. I'm including -8, so bracket. Or you're shading everything to the left of -8 with a bracket closing at -8. The next problem is called a compound inequality. Notice that in this inequality, there's multiple inequalities there. So we have -3 is less than -4x plus 1, which is less than 17. If you just have the variable inside both of the inequalities, there's no variables on the end values of the inequalities. If you just have variables in between those two inequalities, then you don't have to break it down. If there was variables on either side, we'd have to break this down as multiple inequalities, and then we would look at what they shared in common, what's called the intersection of both of those sets. I noticed that I only have a variable inside of the inequalities sandwiched in between those inequalities, so I technically don't need to rewrite it. So whatever I do in the middle of the inequality, so I want to isolate the x inside the two inequalities, so I don't want that positive one there, so I could subtract one there. But if I do anything in the middle of the two inequalities, then I have to do it on the other sides also. So we technically are subtracting 1 on both sides. So we have -3 minus 1 is -4, is less than -4x, which is less than 17 minus 1, which is 16. We need to get to the x by itself. To get x by itself, you're dividing both sides or everything through by -4. But I'm dividing by a negative, which is the same thing as multiplying by that reciprocal. And so since I'm dividing by a negative, my inequalities are flipping. So I have -4 divided by -4, so this is 1, is greater than -4x divided by -4 is x, is greater than 16 divided by -4 is -4. Another way to write this is -4 is less than x, which is less than 1. To me, it makes more sense going from smallest to largest. Just make sure that the inequalities are facing the same way when you flip them as they were before. And so you're looking at everything between -4 and 1. So you have parentheses -4, comma 1, parentheses. Or graphically, -4 to 1. You have parentheses and shading everything in between.